Okay, our last scientist that we're going to look at here is Mr. Erwin Schrödinger, that worked on the model of the atom. And yes, it's the same guy with the cat. So Erwin Schrödinger, basically what he did is he continued looking at the electrons and the energy levels of electrons that Bohr did. And his big thing is he did math. And basically proved that mathematically the electrons in an atom are not orbiting around the nucleus like Bohr said. Because one of two things would happen. So if this is my nucleus and I have my electrons orbiting around, he said either the electrons would circle in and crash into the nucleus, or they would spin and get faster and faster and faster and eventually fling off. And if either of those things happened, the electrons would not be with atoms, and we wouldn't be able to study them and analyze them, but we can. We can see that electrons exist and they are there. So from that and his math and stuff, Erwin Schrödinger came up with this idea here of probability orbitals. And what those are basically, a probability orbital is an area, or a volume, I guess, because we're in 3D space. But it's an area where an electron will exist 90% of the time. So, we come down, we look at Schrödinger's model of the atom here. Basically what he said is, hey, you know, if I draw a zone around the nucleus, the electron's inside that zone most of the time. And it's not necessarily going in circles. It might jump over here, be over here, come back, jump around, right? It's just kind of moving crazily wherever it wants. But it's in this orbital, this area that it exists. Now, a key thing here about Schrödinger's atomic model, we call this the electron cloud model because it looks like a cloud around the nucleus. So there's two key things. Key thing number one is the electrons are not orbiting, but they're in probability orbitals, okay, these areas. And the orbitals still have distinct energy levels. So there are still multiple orbitals. And if the electrons are in a certain orbital, they will have a specific energy. We talked about how Bohr realized that electrons have specific energies and can give us specific energies or colors of light. That is still true. The only thing Schrödinger changed was the idea that rather than spinning around the nucleus, they're just in these zones. And in fact, we actually know what these orbitals look like. So here's a picture of them. So here we see the first orbital is just a sphere around the nucleus. The next one has these little loopies, and this one's loopies in a different direction and a different one, and so on and so forth. So each one of these orbitals has its own energy. And the reason that we draw it more like this one up here is because if I start drawing and say, okay, here's my nucleus, the first orbital is here, that's the first energy level. Here's the next orbital, here's the next orbital, here's the next orbital, and so on. It just starts to get messy, and so we'll represent it here looking more like a cloud. But that was his big contribution, is that mathematically electrons are not orbiting, they're just existing in certain areas around the nucleus.